The worst day ever.
Never mind.
There
It's
we
actually
go.
worse than what I had to do.
All right.
My parents forgot. They're just kind of just like, oh.
So we stopped on Tuesday
Yes.
with 7-2. If I remember correctly. We're gonna borrow a book. I'm gonna borrow your book again. Walk all the way around here every time I look at the book. So the mic can hear me. Just the video is the worst part. So. Oh, I take it back. Yeah, we finished with the tables. We finished with. Yeah, that's right. We talked about probabilities. We talked about basic probabilities. We talked about the charts, meaning that. So, for example, what is the problem on the right side of the page over there, the bottom right? No, correction, top right. What page is this? Let's see. 300, problem 55, where it talks about having choices, tables, and you had to select and determine the probability, etc. Where we're going to take the discussion now is to discuss more of probabilities and how probabilities work. Excuse me. What I'm going to do is also pull up my phone, said book. What is this? Where did it just go? All right, so what we'll do is we will pick up with 7.3. We're going to talk about the other rules that go along with probability. All right, we're going to talk about complement rule. We're going to talk about the addition rule, and then we'll talk about sequential rule, etc. And then we'll finish out with 7.4. Oh, the multiplication rule. That's what I'm looking for right there. And then we get into chapter 8. It's pretty straightforward from the rest. Again, it's very simple when it comes to the concepts of stats again. So, all right, so think of it in terms of this, okay? We go back to this idea, all right? We get a magic hat here. That's what it looks like, right, Nick?
A magician.
Magician's hat, right?
I'm saying, are you a magician?
Maybe.
Can you show me?
No.
Oh.
You can't be a part of the Brotherhood. Or the,
What brother? What?
there was an Arrested Development. There was a thing, Job's Magic Brotherhood thing.
Yeah.
Can't remember what it was. Okay. Imagine for a second you have a magic hat, right? It's got 3 triangles, in this case 6 circles. All right? So if we stop and think about it, we said last time, if I said, what is the probability? And again, everything has an equal chance. I randomly put my hand in the hat and I pull out a triangle. What would be the odds or the probability? Yeah, 3 out of what? 3 out of what? 3 out of 9. There you go. Yeah, remember, it's what you're looking for over the total objects you have. So in this case, 3 triangles.
6 circles.
Yeah. Over 9 total, that gets you to what? 1 over 3,
Yes.
which is about 33%. Okay? So let's think of it in terms of this as well. What is the probability? I randomly put my hand in, and I randomly do not pick a triangle.
So you pick a circle.
What was that?
So you pick a circle.
In this case, yes, it would be but I said not a triangle.
Yes.
Okay?
So a circle.
Okay, but it's not a triangle, correct?
Yes.
Okay, so in that case, it would be what? Anything that is not a triangle.
Yeah. What about?
Okay, so what is the number? Yeah, come on.
Bleh, 6 out of 9.
Yeah, 6 over 9. Okay. So, yeah, and again, so this is not a triangle over the total number of options, right? So that gives us 2/3, which is equal 66%. Okay? This right here is what they refer to as the complement rule. Okay? The complement rule simply states this, says, number 1, that the probability total is always equal to 1 or 100%. So the total probability of something happening, we add up all the probabilities of something happening, it's going to be equal to 100%. Okay? Think of it in terms also, we will draw a magical pi. Okay? Think of it in these terms. The pie, you get 100% of your pie. Your mom's pie, right? Nick, your mom make a pie? She make pies and stuff like that?
Yeah, she makes any
She bake a lot? Doesn't get baked. She bake?
Yes.
Okay, good. Just checking. Hey man, I'm not judging.
She's a nurse.
Oh, shit. Okay, good. Alright. So you go eat mom's pie, okay, the cherry pie, whatever you got here. But what I'm trying to get at is this. If this represents 100%, okay, which we just said right here, the probability of something happening, we sum up all the probabilities equal to 100. And we say the probability of probability of blue is this number, whatever it is. Okay? 2/3 or something like that, yeah. So then the probability on the other side would be the total minus, yeah, exactly right. Okay? So if we think about it like this, we say the probability of A happening is equal to the total probability minus the probability of A not happening. Okay? Okay, so in this case, we rewrite it. It pretty much says probability of A happening is equal to 1 minus the probability of A not happening. And they annotate it by putting a bar above A. Okay? So again, so that's why I said with this, I said, what are the odds of not a triangle? And Nick said, you mean a circle? No. I said, not a triangle. Okay, so what if we changed it and threw 2 blue squares in there? Now I change it and say, what is the probability of not having a triangle? Yeah. We would still add up the probability of this, add up the probability of that, right? And subtract it from 1. There you go. Okay? Excuse me. So again, probability total, and that's a foot stomper, total probability of all possibilities happening is 1. All right? So that means if you have a quality that you're looking for, okay, if you have a quality you're looking for, just take 1 minus the quality you're not looking for. And that will give you the probability of it happening. Okay? I think right now, by the way, they say Kavanaugh has a it's about a 50-50 shot he's going to get confirmed. Apparently, which is today. I just discovered. Maybe tomorrow. Supreme Court guy, yeah. So 50-50. Right? So that means equal chance across the board. All right? But
I
again,
drink beer. I drink a lot of beer, but I've never drinking that much beer before.
blacking out takes a lot of booze.
Yeah.
It does.
I know. But
Small guys like you and me.
Yeah.
But you don't say that when you are someone of that high of a.
Are you kidding me?
Yeah.
Everyone gets fucked up.
Are you kidding me? That's another thing America has problems with for 1 second.
I know, but like.
I
think about it.
I don't drink. I don't get naked. I have no body parts. I'm just automaton. We repress so much. Everything. Emotions, feelings, actions. That's why America has so many issues.
I wouldn't be allowed to become a politician if drinking was the case.
I know. Shit, no one in the military. I mean, hell, John McCain crashed 3 planes, one of pilot training, one of the worst pilots ever.
No kidding.
No, but it's just my opinion though, like, just,
Alright.
I don't think you should say that out loud when you're trying
Why
to
not?
defend yourself from a very serious case.
Someone comes to you and says, Nick, I think you abuse alcohol.
I'll be like, no, I only drink occasionally.
So you say, hey, I did not drink whatever, and move on, blocking out.
I did not have sexual relations with that woman.
Miss Lewinsky.
Monaco.
All right, so if we look at page 301, it says, example 1 says, if there is a 1% probability of winning the lottery, what is the probability of not winning the lottery? Okay, so Nick, the total probability of something happening is equal to what again?
Whatever the total is. Or no.
The total probability
Well,
is equal to,
1.
okay, So if the probability of you not winning is 1, then what is the, of winning, what is the probability of not winning? 1 minus, 100% minus,
Nothing, 36, how did you say?
okay, so let me restate the question one more time.
I was so lost when you read out that question.
Okay. There is a 1% chance of winning the lottery. What is the probability of not winning the lottery?
So, 1 is the total.
Okay. Do you have any other options with the lottery besides winning and losing? Can you tie or some other category we don't know about?
It doesn't say you can't tie, so, no.
Okay, so yeah, so you either win or you lose, okay? So if you have a 1% chance of winning,
So, are you asking, like,
what is the probability that you will lose?
Or no. Oh my god.
I don't know why you're having problems with this. All right, Miranda, so again, you have 1% chance you're going to win. What is the probability you are going to lose? 99%.
You
Is the
seriously
end-
couldn't figure that out?
I'm not right, I'm not here right now.
Jesus, Nick.
All right. So, give you another example. It switches on the next page on 302. Example 3. It says, for A through B, consider the jar with 10 tokens as follows. 5 red tokens, numbered 1 through 5. 3 green, 2 yellow, numbered appropriately. What is the probability of selecting a red or green token? Okay? This is what we refer to as the addition rule. Okay, so first there's a complement rule, foot stomp. Then there's the addition rule. The addition rule says if I have the probability of A plus the probability of B, that's going to be the probability of A plus B. Translated, I just can take the probability of one and add it to the probability of the other. Plain and simple. Okay? So going back to the example we were just reading. All right? We have 5 red tokens, 3 green tokens, 2 yellow. Part A says, what is the probability of selecting a red or green token? Okay? So it says I have 5 red, 3 green.
Yeah, 3 green, 2 yellow.
All right. Then it says, what is the probability of A or B? Correction, not A or B. The red and yellow?
Yeah, what's the probability of getting a red token and a green token?
Red and green.
Red or green.
Yeah, red and green.
Okay. The key word is or.
So it doesn't matter which one.
Yes, it can be either one. Okay? So in this case, how many total, what's the total options? 10. Yep. Now it says, what's the odds I'm going to pick a red or green? 8. 5 plus 3. Very good. Simple. So we get 8 over 10, which is equal to about 80%. Part B says what, Nick?
Part B says what's the probability of selecting a red or number 2 token?
Okay. So each one of these has a number 2. You look at the numbers following them, right? 1, 2, 3, 4, 5, 1, 2, 3, 1, 2. Okay. Part B wants to know, again, we still have 10 tokens total. It said if it, what's the probability of doing what again?
Selecting a red or number 2 token.
Okay. So red or number 2. Okay. So how many red tokens do we have? 5.
And we have 6. No, not 6. 3.
Okay.
3 number 2 tokens.
But under the red count, we've already counted
Green.
the number 2, right?
Yeah.
Because up here we said, yep, there's 5, 3, 2. As part of that, we counted the number 2 token.
Oh, so it's 7 out of 10.
Yeah, very good.
Okay.
So that's about 70%. Okay. Is there a C on that one? I think there is.
No.
There's C? Okay. Awesome. So again, with probability, it's going to ask you or. or is the key word. So with that, you're just going to take the probability of the one, the first one, and add it to the probability of the second one to get the probability total for what it's looking for. Okay? So again, think about it in this term. Hey Derek, this one right here says, what is the probability of red or green? So 80%, right? So what is the probability of not getting red or green?
20%.
20%, very good, because we said it's your P total. So we want probability of not red or not green. That's equal 1 minus 0.8, which is equal to 20%. We can use complement rule for something like that. Okay? Any questions on that? All right, let's do one more. Let's do one of these chart problems. On page 303, it says number 6. It says learners were classified according to motivation and performance. Hey, this sounds familiar. Motivation could be low, average, high. Performance could be poor or good. The results are as follows. Okay. Part A, etc. Okay, so let's set the chart up first. I will also I'll probably post a practice test that pretty much matches what the final exam looks like as well. All right, Derek, tell me what this table looks like again. So what are the two rows? The rows, I can't remember, is it motivation or like?
Yes, motivation first.
Oh, that's the columns, right? Yeah,
Yes.
okay. So motivation is the columns, and it's low, medium,
Average.
okay, and high, right?
Yes, and then total.
Okay, yep, and then we have to set the total row up, yep. And then what are my two rows labeled out here on the left?
Well, it's performance, that would be poor, good, and then totals.
Okay. All right, so give me the numbers that go, so starting with the low column.
14 and 2.
14, 2, that gets me to 16,
Yes.
medium, or sorry, average.
8 or 6, 8 and 6.
Okay, which gets me to 14, high.
3 and 7.
3 and 7, which is 10, and then total.
25, 15, 40.
So 40 total students. All right, part A says what, Nick?
Part A says one learner is randomly selected from a group of learners. Find the probability that the learner has low or average motivation.
Okay, so we're gonna randomly pick one, part A. Randomly pick one, and ask what are the odds the individual has what again?
Has low or average motivation.
Okay, so has low or average motivation. All right. So the probability of low or average. Okay. First, again, any probability is what we're looking for over the total. So the total is what, Dan? Total.
It's gonna be 30 out of 40 for A, right?
Oh, you're skipping this
Oh,
stuff.
sorry.
Yes, 40. Very good. Now there's 40. That's good. You're skipping ahead. I like this. I can speed this up now. All right. Okay, so where'd you get 30 at on the top?
Headed up, low and average, 16 plus 14.
Very good. 16. Does everyone see where you got that from?
Mhm.
Okay. Nick, see where you got that from? Okay. So that would be 30 over 40, which is 3/4? 25%? Okay, what's part B? Nick.
Part B, one learner is randomly selected from this group of learners. Find the probability that the learner has average motivation or good performance.
Okay, so wants to know what is the probability of an average motivation or good performance. Okay? So we need good performance and good motivation. I'm going to draw those lines there to represent the columns lines. Okay? So again, the number on the bottom is what, Dan?
Sorry, what are we, which one are we doing?
Part B. It says what is the probability that we randomly select a student who has good performance or has average motivation? Okay? Denominator stays what?
So what is it? So good, 15.
Okay. So 15 here.
Yeah.
Okay.
And that's, what is that, the bottom one?
That's so if I take the probability of the good,
So what is it?
well, that's
15?
probability of the average.
6 over 40? Or, yeah,
Okay, so the bottom's 40.
yeah.
Okay. So let's look at this. What is the probability of good performance? We look over the total, it's,
15.
yep, it's 15. Now we need to know how many of them have average.
14.
But we've already counted
Okay.
these 6 students.
So 8.
8, very good. 15 plus 8 is 23. When you divide that, you get what? Anyone?
On here it says 14 plus 15.
14 plus 15?
Yeah.
Why would you
minus-
count them twice? That makes no sense.
Well, it says 14 plus 15 minus 6.
Which
All
is,
over 40.
which is 23.
Oh, okay. You just did a simpler one.
Yes.
Okay. My
I remember my first day reading a book. It's amazing. You gotta go home and be like, Mom, I read a book. The math book.
I do need to go home.
57%.
57%, very good. Okay, so with this, these charts, and you'll have one of these on your exam and one on the quiz, it's just paying attention. Okay? No, not that part. Paying attention to this. This, like, did it get counted already? Because there are those trick questions in there. Alright, is there a C?
No,
No C?
I don't
Just A,
think
B?
so.
Okay. You guys want another example?
I think I'm good. I just
Think
need
you're
to-
good? Derek?
I'm good.
Okay. Dan?
I'm good.
Okay. Alright. So again, that's just addition rule. Probability of A, probability of B. So again, last example, 5 of us in here. Yeah. Actually, it's a bad example, forget it. Because I was getting ready to say, oh yeah, we'll divide the class. I was like, no, that's not gonna work. Boys, 4 boys, that's not gonna work. I was like, okay, bad idea, we'll stop. Alright. So complement rule tells us again, total probability is equal to what, Dan?
Equal to 1 or 100%.
Very good. Foot stomp, foot stomp. Okay? So if the probability of A happening is something, sorry. In this case, probability of A is just equal to 1 minus the probability of A not happening. Okay? And you tell your wife, hey, I'm gonna go buy this. I don't think so. What's the probability of it not happening?
Yeah.
100%. Alright. Okay. Then the other probability thing we look at is what's called multiplication. Okay? So complement, addition, multiplication. And now with multiplication, we're going to look at something. What is the probability of something happening in sequence? Okay? So, like I said, we talked about complement. We talked about addition. Now we're going to talk about multiplication. And the key word here, and I spelled that wrong. You can't read it anyway. The key word here is sequence. Something happening in sequence. Okay? What is the probability of A happening followed by the probability of B happening? Okay? Let me think of a good example here. What would be... Okay. No, I gotta use a non-military example. Since we're outnumbered here, Dan.
Go for it.
It's all good. Okay. Let's say I was gonna think of a real world example, but we'll skip it. So let's go back to the magic hat here, the hat of magic, right? Magicians are still cool, right? Right? I'm lying, they're not. Okay, but let's say this. What would be the probability I randomly stick my hand in the hat and I pull out a triangle? Miranda? Oh. What was that? And what is that?
11 or 8.
11 over 8.
I mean, bleh.
How many triangles are there?
9.
How many triangles are there?
Oh, 3.
3.
I thought the total was 11. Because there's.
Well, you said 11 over 8.
Oh.
So 3 over how many is there? 11. Okay. Alright. So what if now now it says, what is the probability of me putting this, hey, 3 and 11. Now I put it back and I say, what is the probability now that on the second draw I will get a circle? Okay, well what's the probability of getting a circle? Dan?
6 over 11.
6 over 11. Alright? What we're saying is what is the probability of doing triangle followed by circle in that sequence? In order to determine that, we just take the probability of the first one and multiply it by the probability of the second one. Okay, so again, the key word is in sequence. So if we multiply it out, we get what? 3 times 6 is 18 over 121. 11 times 11. Calculator for me, anyone?
Yeah, that's 18 over 121.
11 times 11?
Yes, 121.
Yeah, that's what I got, 121.
Yep, that's it. 11 times 11 is 121.
Oh, okay, no, I meant divide. 18 divided by 121.
Oh.
Sorry, my fault. I was like, oh my god, I thought I did this right.
That's still the same.
Oh no, 18 divided by 1.
See, I'm getting confused.
No, it's all good, man. It's all good. It's probably like 15%.
14.
14.
Okay. What's the decimal point?
0.87.
Okay. We'll go with 8. Yeah. So it says, what is the probability of this happening in sequence is 14%. Okay? So that is the multiplication rule, which says multiplication. So the probability of A happening in sequence with B is equal to the probability of A happening times the probability of B happening. Okay? The key word is in sequence. Okay? In sequence. So if I look at the book, what awesome examples we have on this one. This is the next chapter, 7.4. So 7.4 says, okay, page 310. Page 310, bottom, example 1 says, consider the jar with 10 tokens again. 5, 3, 2, red, green, yellow. All right, red, green, yellow. And all tokens have an equal chance of getting picked. In this case, it says, what is the probability, part A? Part A says that you draw 2 tokens without replacing the first token before drawing the second token. Okay?
What page is this?
This is page 311. Just like the band. Alright? So you're going to draw 2 tokens without replacing the first token before drawing the second token. What is the probability of drawing 2 red tokens? Okay? So what it's saying is this. Again, we have 5 red, 3 green, 2 yellow. Okay? What is the probability of drawing a red token? Just 1 red token.
5 out of 10.
Yeah, 5 out of 10. Okay, so now I've taken the red token and I've put it on the table. Now I go in and I say, now I'm going to go back in my hand, and what are the odds now of picking out another red token? 4 out of 9. Because in this case, we got rid of 1. So it would be 4 out of 9, meaning that there's 1 less token in the hat, and it happens to be red. Alright, we multiply them together, we get 20 over 9 D, which is equal to
2 over 9.
2 over 9, which is equal to
22%.
22%.
Why do you look at me like that?
I know, because I'm watching you watch whatever Miranda's watching.
It's very intriguing.
I'm actually like paying attention, so.
Something zooming in, a lot of action. I can tell that.
It's Ant-Man and the Wasp.
What's the probability of Ant-Man getting punched in the tank? No, I'm just kidding.
I don't know.
I don't know, I never saw the movie. Okay. So in this case, what would be the odds if I picked first a green token, followed by a yellow token, and I put it back? So so what are the odds I pick a green, put it back, and then pick a yellow one? Alright, so up first, what are the odds I pick a green?
3 out of 10.
3 out of 10.
And then
Okay.
2 out of 10.
Of course my husband calls. No one calls. Times what?
2 out of 10.
2 out of 10. Very good. Because again, the token's been replaced. That same token can hypothetically be picked again. So in this case, it'd be 6 times 10, or 6 over 10, or 100.
Yeah.
There we go, much better. Which is equal to 6%. And you can go as many sequences as you want. So what if we say it was in order, red, you put it on the table, green, you put it on the table, and then yellow. Alright, so odds of picking red? 5 over 10.
Yes.
Alright, we don't put it back. What are the odds of picking a green?
3 over 10? Oh, wait.
That's the next one. Now we've taken that red token we picked, we put it down. Go back to the next one. So how many are in the hat?
3 over 9?
3 over 9. Very good, yep. Because there's one less one in there. And now we take that one, we put that on the table. Go back for the third time. And we say we want a yellow.
2 over 8.
2 over 8, very good. Multiply those across. 5 times 3 is 15, times 2 is 30. 10 times 9 times 8 is what? 7,200? Yep. When you divide that out, what do you get?
1 over 24.
Okay, which is equal to what percentage-wise?
4%.
Okay, sounds good. Alright, 4%. Alright. Any questions on multiplication rule? I think the probabilities are pretty straightforward. Once you understand what they are and how they work, I think they're pretty straightforward. If you understand again sequence, understand that I can put a selected object back. That's pretty much what we're looking for, that you can understand that basic concept. All right. Oops, sorry. You guys want to do any other examples of this? This is it with probabilities. That's pretty much it. If you understand those 3 concepts.
Seriously?
Yeah.
That's easy.
Probabilities to me are so easy for basic stat, and this is even basic, more basic than this is so like, this is like an extra large pumpkin spice latte. Okay. How about this? Take a break. Get up, stretch your legs. Come back in 10. We'll keep going.